Before I introduce our speaker today, I'll just give a few housekeeping rules. As the speaker will be giving his talk, please ensure that you are muted to avoid distractions. And also feel free to ask questions in the chat, and then we'll ask the questions to the speaker at the end of the session. So please join me in welcoming our distinguished speaker for today's webinar, Frank Midigo. With a wealth of experience in Elixir, Frank is a respected figure in the Elixir Kenya community. Today, he'll be sharing valuable insights on testing in Elixir. He'll be sharing best practices and techniques when testing. Without further ado, welcome, Frank. The floor is yours.
All right. Thank you. Can you hear me well? Just to confirm.
Yes.
Perfect. Yes, thank you, Paulette, for the good introduction. Let me share my screen. Right. Could you confirm that you can see my screen?
Yes.
Perfect. All right. Happy Friday, everyone. Today I wanted to talk about some tips in Elixir. I wouldn't necessarily call it tips, but just some of the tricks that I have picked during the course of my time when I've been writing Elixir. So the talk will mostly be focusing on the fact on how to structure your code so that you can write your test. I have this saying that test is code, so you have to include test in your code bases. So I'll be talking about two main areas. One is around Gen servers, and then the other one is around external APIs. So before we get started, just to do a quick introduction to test for those who are new to this. So I want to define. So I don't know if I can share this slide book so that you people can follow along. No, not yet. I guess I'll just share it after the talk. So I have defined a simple module for calculating. It's just adding two numbers, right? So if I were to write a test for this will be it, right? So we can test that if I give my function 5 and 6, then I expect the value to be 11. All right, so let me just start everything here. I can't execute this. Let me disable the presentation mode. Perfect. All right. And let me compile this module. All right. So we can write this simple test, right? Let me evaluate. Perfect. So we are now sure that this function is working, right? But then users will always come up with some funny characters. So let's say someone decide to give our function a string instead of an integer, right? What will happen in this case? Let's see. So our function will break as expected because you can't add a string to a number, right? You can only add numbers. So you can decide to improve your function and handle such scenarios because some users may actually literally put in characters. So let's handle this scenario here. I just redefined this module. So yeah, if at all, so this will be the the first clause that we had there, but then I'm just adding guard clauses for when they are numbers and then handling the cases when they are strings. Okay, so right now, if we try this, let me compile this. And so if we do the same thing that we did up here, we now expect to get a value, which is 3, because we added these classes, right? But there's no guarantee, because if you are working in a code base, anyone can come and add their own clause here, because maybe someone might decide to say, okay, fine, we don't only want to handle strings, we also want to handle another data type, say, which character can I think of? Let's say a list, okay? Let's just be generous. When we have a list here, number 1, and then maybe we can decide to take the first element from our list, right? Yes. So with this, we essentially added a clause that allows our calculator to add a list to a number if the list contains a string or a number, right? Like this. If we do this, this will still work. 3, yes. But then there's really no guarantee that this thing will work forever, because someone might decide to modify our code, right? Like in this particular case. So if we add a test like this, we are always sure that our code is always correct. And so regardless of who is touching our code, we can sleep better at night. Perfect. I hope now we get a glimpse of what I'm trying to do here. So I will go to the first section, which I talked about. How can we test gen servers and supervision trees? This is one of the areas that I really struggled with when I was beginning. So I had it here. Right. So this is a simple gen server. What it does, it adds, it counts every single time, right? After every 30 seconds, it counts kind of like the number of calls that have been made. So, so we start the gen server here, the callbacks they need, handle info, and update state, right? So when the gen server starts, we call the update state function. What this does, it sends a message after the given interval. So in this case, we've hard coded this interval to 30 seconds, right? And then, so it sends the message update. So after every 30 seconds, this callback here is going to be called. So we can test that here. I already did this. Let me comment out. So if you have to test this, so you've already tested it, the result is 0. Actually, we can also do another test. I hope 30 seconds has not yet elapsed. Let's just do it again real quick. Yep, not yet elapsed. So we can do this. Oh no, is this thing running? Started it. Yes. So it is running. So after 30 seconds, this got updated to 1. And then after another 30 seconds, we will update this to 2. So imagine you are to write a test for this. Okay. The test will go like this. Here's an example. So we start our gen server, right? And then the only way to be sure that our gen server is actually working is to wait for 30 seconds, because that is what we want to assert on. So let's try this. Let's see how long it takes. Yeah, it's taking too long. So already we've already identified some places where we can improve on, because you don't want to have your test waiting around for 30 seconds. We can improve this. And in this case, we should aim to reduce this interval, right? So we can reduce this interval to favor our test. Oh yeah, yes, 31 seconds. So it took 31 seconds. So imagine you had 100 tests. This will take ages to finish. So in order to refactor this, we need to figure out a way to remove this hard coding and pass it around to the state, or even to the init function. So this is an example of how we can do it. So we will define a struct called state. And there's also a pattern that you can check. So instead of having your state being generic, maybe a map, a plain map, or a plain list, you should have it in a struct, because at least this way you can be sure about the keys that are there. So we've defined our state here, and also notice we've also defined our interval here with a default value of, oh yeah, I'm doing this twice. So we can take this, have it in here. Perfect. So it starts, so it has a default value of the 30 seconds, which is the same thing as what we had up here. And then our counter also starts at 0. It's the same thing that was here. Okay, so the rest is kind of the same. So the only difference here is when we are now calling update state, instead of calling the 30 seconds, right? It will be based on what is on the state that we passed around. So the default value will be 30 seconds, but then we can change this value to suit us. So here's an example. So when initially, how did we start it? Initially, we started it just with the name, right? But then here we're starting it, and then we are adding an interval of this 2 milliseconds, by the way. This 2 milliseconds. If you want to add it, if you want to set it to seconds, you have to multiply it by 1,000. But then we are setting it to 2 milliseconds. And then this way we are sleeping. We are setting our process, our test process to sleep just for 3 milliseconds. I think that is acceptable. It is way less than the 30 seconds. Okay. This for a second. So now let's try to evaluate this. So we have our improved counter. Let's test this. We have a problem. So the state is being set to, the state that is being got here is 0. Wait. Okay. Yeah, I see what happened. So we called, they're still calling the previous module. Should be improved counter. Is that the correct module name? Right. Let's reevaluate this. I hope. Okay. So we were expecting it to have 1, but then it already has like, oopsie, what happened? Yeah. Okay. Sorry about that. I was looking at this error message. So we're expecting the counter Okay, yeah. So you're expecting the counter to have 1, right? And actually it has 1. It has 1, but then the interval, we were not matching on the interval. So instead of doing a strict match, let's just put a match on the counter. So if we evaluate this, perfect. So now our test will be passing within, okay, 0 seconds. Yeah, that is an improvement. Something else to note, notice I added this test here. So when starting your processes in the test, you need to, there's this helper function called start supervised. It is advisable that you start your processes under the test supervisor. So like in this case, this is kind of like the same thing, but then we define a child spec, we pass it down. We're talking about the improved counter. I'll go to update this. And then we now start it under the test supervisor. This way, when the test supervisor is going to shut down, it's going to shut down that particular gen server correctly. Remember, this way, the only way for the gen server to stop will be if our test gets killed. If the process gets killed because it is linked, it's going to be killed as well. But then in order to shut down gracefully, it's advisable that we start it under the supervisor. So this will be the same, should still work. So you haven't given it the name. So, oh, no. What? Where was I? Okay. So now I've given it the ID. It is saying undefined variable name. We'll have that. So let's evaluate. Error exit undefined improved counter. Oh, that's a lot. Yeah, I think there's a typo somewhere. There's something I've missed. But then you need to define your child spec and then give it to the start supervised function, and then this will get started in the test supervisor. I think there's something. Let's see if I can fix this. Find improved counter. Start link, name, interval. Yeah. I don't know what I'm missing here. Yeah, that won't work. I'll revise this and then update it. So yeah, that's just it for states that are changing. The other alternative that you can always do as well is to now, instead of you can add this to, let's say, it's over here. So here. So we can decide to set this config in the application environment, right? I don't know if we can do that here. Would be interesting. Let me add it. Yeah. That would end. What is our application? Interesting. this work. And let's see if we can do this. Interval. Oh, okay. And then we can come and pick our configs here. And then where is that? Yeah. It's config application.getEnv. My app. Let's say the config is under counter. Perfect. So you can have this and then merge it. So our state will now be. So let's merge in this particular. These two configurations. Config. Configs. Okay, perfect. So doing this will also almost help us. So we don't have to pass around. Okay, we can have this in our configuration. So let's try this. Okay. Let's try getting. So it is called improved. So where is the name was improved counter? Okay. And then let's see what is the state. The process is not alive. What is the process associated with the name? Okay. So we have to start it. Okay. Okay. So starting. And then we don't pass in any. Okay, let's give it a name so that it doesn't conflict. So let's sleep for. We set the config to. Okay, let's set it to 1 second. And let's let this process for 5 milliseconds. So we're expecting it to have at least 5. Oh, great. Yeah. So you can also do this as well, instead of having to hard code the particular interval on the module itself. The other part, how you can actually test Gen servers. So let's say you want to test that our Gen server is shutting down. Let's say we want to test that it actually shuts down correctly, right? So you can always monitor. We can monitor our Gen servers. Yeah. So let's start the Gen server again. Or maybe we can let's have another process, another task instead. Let's say we have a task that writes some file, but in our case, task that give it another function. Let's say you had this task just as it's a one-time task, and its work was to go and fetch some file somewhere and maybe write it in your file system. Okay, in this case, let's just assume this process takes 20. Let me set for 30 seconds. So maybe a minute to give me more time to play around with it. So there's one minute, right? If you want to test this, you might want to test that it finishes successfully, right? One way to do this is just to use the tools that we have in OTP. So we can decide to monitor this task. Okay, let's call it task. And you can always assert on based on the exit message that this task sent out. So once you monitor it, right? Only way to do that. And then if you get a message, okay. So we have our task, it's running, and then let's kill it. Task, and then kill. Okay, oh no. I can't do it in here. So this has to execute. Okay. Yeah, I didn't consider this wisely. Maybe I can shift the terminal so that I can just show this. And let me open up my AX. Tab AX. Okay. Oh, yeah. So notice this one here, it exited with the normal exit code. But then I wanted us to test to say to check if it exited with another reason. And then we can write a test for that. Okay, so let's do the same thing. Perfect. Let's monitor it. Perfect. Oh, how am I going to do this? Oh, okay. Okay. So I have to kill it first and then receive in the same process. Oh man. Let's just do it here. So let's kill this task. Yeah, so it was linked. Okay. Now that isn't so helpful. So let me do it here. So I want to kill it, but then after I wanted to kill it after. So you have it set to 60 seconds, right? So let's do this. Let's kill it after 10 seconds. And then, so if we receive a message called kill, what we will do. And then, so we will see the message that gets returned here. So it should not be the normal exit code. Okay. Yeah, I think this can work. Yes. So let's enable it. I did send myself a message. Oh, okay. Test send self. Kill that guy. Evaluate. Oh, man. Let's stop this guy. How can I show this? So I want to also, let me do it here, but I don't want to link it. Let me not link it to this parent process because it will kill our process as well. So let's monitor it and then, yeah, send after, let's send it to ourselves, say, kill process. And this should be after 5 seconds. Okay. Why do we have killed here? Killed. There must have been. Yes. And then open this. Oh, goodness. Okay, let me stop this whole thing and start it afresh. Session. Then 6 hours. So we don't want this, but we want this guy. Okay. Right. I don't know how to do away with this cute guy. Setup. Okay. Oh, it has to run all this. Okay, I see. Okay. That's new learning. So it has to reevaluate all cells from top. Evaluated. Okay. This guy is returning true. No, we don't want it to return true. That's the message. So this guy, okay, yes. So now we have, yeah, we have it here. Perfect. So we can test, if you are writing a test for, let's say, a function that was testing, that was doing this particular process, this particular task, we can monitor this particular task in our test. Let's do it here. That's okay. Let's have it in our module. Test. Task. Really long task. So let's write a test for this. Okay, module. To that's right. So yes. Yeah. So we need to start our task here. So assuming it is started in some supervision tree elsewhere, right? And then we want to test that it does particular job correctly. So again, notice we've come to another really long task that is happening here that takes 60 seconds. So the moment you have some part of your code base that calls an external, like does something really long, but then you want to avoid doing this. I think I'll cover that next. But then for now, let's just wait. So sometimes you'll want to mock at this particular activity. So instead of waiting for 60 seconds for your task to complete, you can mock this particular function and then have it return almost immediately. But then in our test, we just do the same thing that we did there. So okay, right. Okay. Task done. Really long task. Yeah. Now I'll set it to 2 seconds. So I don't have to wait. And then there's this xUnit function for asserting that we received. Let me just check it here. Set receive. So we can assert that we are going to receive a particular message after this number of timeout, right? Yeah. Set receive. Those are, what's it looking like? See, I've gotten rid of it. Then right, some ref here, something here. I can't remember what this was called. Let me just use it instead. Then is always the exit code here, just normal. And then we said we are waiting after 2 seconds. So we have to wait here as well for 2 seconds. So if we do this, we'll now wait for, so it means we are waiting for our task to finish. And then after the task finished, we are now sure that we can now test, we can assert on, let's say this guy was doing, we have it. That. Oh, we have that. Yeah. Now where do we have this? So we can say before we did this, file that exists. We know that this guy doesn't exist anymore. Then after it does exited, we can now set that it exists. I didn't run the test. Next, I need to run. Let's evaluate. It's waiting. Application will not matching after 2 down rev state. Okay, now what happened? Let's set it. 3 seconds. Okay, Neil. Oh, okay. So we already have our file. So let's remove it here. So before our test starts, let's remove our file and reevaluate this. Hey. So the down reference process. Okay. So I missed this down reference. This is the PID. It's the PID. Yeah. So this should be it. Yes. That's this pattern. So this is how you can test. This is how you can test asynchronous code as well. Right. I think that's all that I had for the gen servers and asynchronous code. I can see almost out of time, so I want us to brush quickly through the external systems one. Oopsie, we don't have that. So assuming you have an API, you've defined your code to call a certain API. Like in this case, there's the JSON placeholder. So if we evaluate this, let's just install this dependency. Okay. Warning base URL. Oh, let's use it. Let's evaluate. Perfect. So right now, if we do dot fetch user and then we give it 1, we are expecting some response. So assuming you want to have your test, you wouldn't want to call external systems in your test, right? Because one, it might take too long. 2, you'll be adding your credentials to the test, suite. And if at all there's a failure on their end, then it means your test will be taking longer to run. So in this case, in this particular scenario, I would advise that you mock the response from the particular endpoint. So there are a couple of libraries you can use. I think there's bypass. There is bypass, but then I prefer to use mocks. So with mocks, you need to define your client as using behaviors. Okay, so like in this case, we need to define a behavior. Because in this case, whatever we want to mock fetch user, right? But then we don't want to go through the JSON placeholder. So we can define fetch user as a callback, fixing an integer. It's not ID, and then it's supposed to return hey what, right? Error response, I guess. Okay, yeah. So we can define a callback to do this. And then, so we have a placeholder API, there's a callback, and then we can use mocks to kind of to mock this particular API. So in this case, if you are writing our test, so let's recompile this. Oh, so I need to add mocks. Let's come here. Mocks. 1.1. Simple. Okay, perfect. So we can then go ahead and say, let's call mocks, and then let's define a mock. Right. We want to define a mock called test. Let's call API mock. Okay. This API, and then it is for this guy, the placeholder API. Okay. So this way, if we are writing a test that user, I really hope it's work. Okay, first some time, hopefully. So let's start XUnit here. Then let's use XUnit. Yes. So I wanted to test this guy. So with mocks, we can do this. Oh, I forgot to import this guy. We just copy paste this. Wise. Complex. Guy. And then you make sure that we are verifying our mocks. So we had our, so we need to define your expectation, right? We are expecting that a function called fetch user is going to be called, and then it's going to receive an argument, and then using that argument, you need to return a certain value. Okay. So ID, we are expecting a value from this. So this way, it won't really go and hit the endpoint in real time. I'll just copy this. Let me just copy it. Okay. And then it's ID, start ID, email. Let's use values. Okay. So we can test and say, so we're expecting this guy. So whenever we call our, but then we haven't really defined which particular we haven't defined which particular model that we want to use. Let me just finish defining this. Well, do we still have some time?
Yeah.
So I will expect, so we can say we can define. So now we want to have different clients for different environments. So this way we need to, so we can set a configuration to say that during the development or production environment, we want to use this particular client, but then in test, we want to use a different client. So API, just call it client to get in. Okay. This is my app. And then the environment here that we wanted to use was placeholder client. Let's just call it this. And then get env. You can always give it a default value, right? Let's check here. Send it get env. Only on the application environment, yes, the default value. So you want to fetch the configuration for the placeholder client, and then we'll tell it that the default value to use is this guy. And then so we need to define, let's define our, so I think I'll need to define, let's define our behavior separate. That will now, or maybe we can even use the same module. I don't think we need to do this. So yeah, blah, blah, blah. Okay, yeah. Actually, I don't even need to do this here because we are using the same API. So I'll need to do this in the test. Oh, but how will it reach here? Now we need to do it. Okay. So we need to define. So let's define our placeholder client to, and then it should be the one that defines this particular callback. Okay. So when someone calls, so let's define fetch user ID to And then this now defined here. Yeah. So this way you can do this. Client dot fetch user ID. Okay. So let me evaluate. So this way we have our client. So it is the client that it will be ID, such type ID. So it's essentially an ID. Okay. So it means in our test, we'll now be we'll no longer be mocking this guy, but now we'll be mocking our client. Okay. And then before we start our test, we now need to change the configuration, right? So let's set it to use our mock that we've just defined. Here. Okay, perfect. This is it. So now we expect that it's this module that's going to be used instead of the other module here. But then, so we are expecting, okay. So whenever we now call placeholder client, where's our module? Response with the client to create user. Let's give it 12. So we want to assert that the response. So the response will be response.id. Okay, yeah. ID should be 12, right? We can also assert that the email will now be this guy, now 12+test.com. Okay, now let's run our test. Cannot invoke outside the module. Where did we define our, okay. Yeah. So we have to find a module. Test. And okay, and that works. So let's run this. ID, it has returned ID as nil tweet. Return the correct thing. Let me inspect. I want to inspect the value here. Inspect. Evaluate. Then let's evaluate this. What happens? It is returning an empty map. Okay, empty map. Did I miss anything? I don't think I missed anything. So then we're telling it to move. Yeah, I don't think I missed anything. Unless there's something that I missed here. Let's see. We have a setup. Yeah, we have the setup, we have the test. Which is does it reach here? Inspect ID. But so it didn't add this to the environment variable. Oh, it is keten. Okay, goodness. We want to put this environment. Oh man. So put yeah. That was to be it. Oh yeah, nice buffer. That was a problem. So now it didn't go through the real. It didn't go through the real endpoint, but rather through a mock client that we defined. Yeah, I think we are way past time.
We have two questions. Sorry for background noise. So I think the first one is, JW, can you just unmute and ask the question? I think it would be easier that way.
Let me open the chat as well. So saying I noticed something in the past. Is it CW text, right?
Yes.
In the first part that failed, will it be due to time being too much than required, as in we put 30, which is 30, no, this 30 seconds. Oh, I think that was in the previous notebook here. Was it here? Yeah. I think the reason why it was failing was because I was trying to do something and then it was evaluating from the top, going to the bottom. Right, and then there's another one. So in the mocking, you have to ensure that you understand exactly how the API works, which largely depends on the API documentation. How do you ensure that you are covering all the edge cases? And what are other options that can be used instead of mocking? So the whole reason for mocking is to avoid making that particular request. But then, so you can always write an integration, one integration test. So like in this case, we can decide to define a test that does the actual fetching. It hits that particular endpoint, but then you can add a tag, right? So like in this case, we can decide to have a test and say tag, okay, test does not, rather, okay. How can we call it? Fetch user makes request successful. Let me close this. Next request. Okay, and then you can give it a tag so that you don't have to run it every single time. Will request. You can always configure X unit. Okay. And then tell it to exclude. Why am I suffering like this? It's the documentation here. So configuration. What was I looking for? Configure. Configure. And then, yeah, exclude, blah, blah, blah. See the filter section, make sure it case. Yeah. Okay. I think if I say exclude real requests, and then we can now stop. We can stop something called stop. So we can interchange. We can interchange the placeholder API, and then instead of using the fake one, we can use the real client that we had. Okay, this guy. So you can write a test that actually makes the request, just to avoid having to avoid that fear that maybe something can break. So it is actually good to have an additional test that makes that real request. And then in your test that excluded, and then maybe in the local environment, you can now run. Does this one have, I don't know how I can have it in here. But then locally, you just run mixed test, include test, slash include, you give a pull request. Yeah, and then it will run only this particular test. I hope that answered the question.
Yeah. Any other questions? You can just unmute and ask.
Stop sharing.
I guess not. Well, thank you everyone for coming today to the webinar, and thank you, Frank, for giving us an interesting talk on testing. We hope to see you next time.
All right, thank you.